Hi everybody, this is going to be the last video in Chapter 5. We are talking about systems of linear inequalities. So at this point, you've seen systems of equations, you've seen linear inequalities. We are combining the two ideas together here. So a system of linear inequalities is just when we have two or more linear inequalities together. Now, the solution here, if you think of a single linear inequality, the solution is any point that's in the shaded region of that linear inequality. Well, for a system of linear inequalities, we need to make sure that we're choosing points that are solutions to each inequality in our actual system. So we're going to see what that looks like graphically. So let's start here by graphing each of these linear equalities that we have. Okay, we've got y equals 2x minus 1, so I'm going to do this in green. We've got a y-intercept down at -1, a slope of 2, so you can think of that as 2 over 1. We're going to go up 2, right 1, up 2, right 1, up 2, right 1, and then we can backtrack here. Now, before I connect, let's stop and think if we're going to have a solid or a dashed line. Since we have a strictly less than symbol here for our inequality, we're going to have a dashed line. And then we also know that the less than symbol means that we're going to shade below. So let's go ahead and connect with a dashed line here. And then let me get a highlighter, and we are going to shade below this line. All right, let's do green again. So shading below the dashed line here. So we're going to shade this entire region. Okay, so any point inside of this shaded region, the green shaded region right here, is a solution to that top inequality only. We need to graph the second inequality before we can find the solutions to this system as a whole. So our second inequality here, I'm going to do this in blue, is y is greater than 2. Okay, anytime it's just y in a number, you can think of this as having a slope of 0. Okay, a slope of 0 means it would be 0x plus 2. The point here is that this is going to be a horizontal line. Okay, it's going to be horizontal. It's going to be dashed because it's greater than. And we're going to shade above because of that greater than symbol. Okay, so a horizontal line at 2. So we've got a y-intercept here. And then our horizontal line is just going through side to side, left to right. We said it's dashed. And we said that we're shading above. So let me get that highlighter again. Let's do blue this time. So we're shading above our horizontal line. And you can see here that there should be some overlapping. Okay, there is an area where the blue and the green are overlapping in this top right corner. So I'm going to do this in pink here. Okay, it's overlapping in this area. Okay, this is where we have shared points. Everything in blue is a solution to the bottom inequality. Everything in green is a solution to the top inequality. Where these two shaded regions overlap is where we find the solutions to the system as a whole. So you can pick any ordered pair in that shaded area, and it's going to be a solution to both inequalities. For example, I could pick the point right here, which is going to be the point 4, 3. That would be a solution to my system of inequalities. Another example would be the point, let's say up here, where we have an x value of 5 and a y value of 4. That would be another solution. Okay, there are many ordered pairs that you could choose. Okay, there are an infinite number of points that are in that shaded region because our graph really is going to never. So these are just two possible solutions. Now, places where you look to find things that are not solutions would be the area that isn't shaded at all. So this point down here would not be a solution. Okay, it's not going to be a solution to either of our inequalities. So let's see, we can put the point -3, -2. And then another example of one that's not a solution to the system would be right here. Okay, even though this point is in the green shaded region, this point of 2, -1 is only a solution to our top inequality. It's not a solution to the bottom inequality, so therefore it's not a solution to the system as a whole. Now, sometimes when we are doing these systems of linear inequalities, we're going to have to do a little bit of work at the beginning to make these inequalities graphable. If you look at our top inequality, it is not in slope-intercept form yet. So we need to do that first. We need to solve for y to get this into slope-intercept form before we actually go about graphing. So to do that, we're going to subtract 8 from both sides first. And then we're going to divide by 4. So we get y is less than or equal to -2x plus 3. So this is going to be my top inequality. Okay, we have a less than or equal to symbol. So we're going to have a solid line, and we're going to shade below. For our second inequality, okay, it's already in slope-intercept form, so this one's ready to graph as is. The greater than symbol tells us that we have a dashed line and that we're going to shade above. So let's go ahead and do that. In blue, we've got a y-intercept of 3, a slope of -2. We said it's going to be a solid line, so let's actually connect our points all the way together here. And we're going to shade below that line. We'll shade the whole region in here. Okay, and then with the second one, we've got a y-intercept at -2. We have a slope of +1/2. And with this one, we know that the line is just going to be dashed. So let's connect. And we are shading above the green line here. So you're going to see some color change. Okay, where the yellow and the blue shaded regions are overlapping, okay, that green shaded area that you see, that is where we're going to find the solutions to our system of linear inequalities, because those are the points that make the top and the bottom inequality here true. So to find our solutions, we can pick any points in this region. I could pick the point -2, 0. Okay, that's going to be a solution. I could pick the points, let's see, we could pick the point 0, 2 up here. And because part of this green shaded region is bordered by a solid line, we could also pick points on this solid line that would be solutions to our system. I can't pick a point that's on the dashed line, but I can pick points on the solid line, and those will be solutions to my system of inequalities. So let's see, that would be the point -1, 5. And just like the previous example, for points that are not solutions, we can look in the unshaded region. So here at the point 5, -1, that's a point that is not a solution to the system. I can pick a point that's just in the blue shaded region, so -1, -4. Or I could pick a point that's just in the yellow shaded region, which would be 3, 2. And again, there are a lot of options here. These are just some examples. So the key ideas here are that when we're graphing a system of linear inequalities, we're looking for points in the overlapping shaded regions. Each inequality has its own shaded region. We are looking for the points where they overlap. All right, everybody. I hope you have a wonderful rest of your day.